Cool. So Julian signed me up for this, and I made this deck today. The name of the meetup was Cookbook Testing with TravisCI and DigitalOcean. I didn't really get around to the TravisCI part, so we'll do that live at the end. But the DigitalOcean part, I totally did. So, right. So I'm assuming y'all use Chef. Yes. Uh-huh. Who tests their cookbooks? Yeah? Sweet. Who's not testing their cookbooks? Okay, all right. So, I'll teach you how to do that. Cool, so this is me. Who am I? I am an early ops coder. Been there for about 3 years now. I started out, we had a group called TSE, Training Services and Evangelism, so we'd do everything under the sun, right? Like we'd go and do conference talks and training and consulting and pre-sales engineering, and luckily we have other people to do that crap for us now, so we don't have to do that. And then I became Lord of the Cookbooks, like, I don't know, like 6 months ago, somewhere in there. And we're building the community team up to help, like, with iron out like the contribution process and everything, so that we can make Chef better. So that's me. I guess, who are you? I mean, I know who these people are. I know who those people are. I know who those people are, but I don't know who the rest of you are. So just for my benefit, it will help me if I know what dialect of dork to speak to you, if you might tell me a little bit about your background and what you're doing here, starting with you.
I'm Stephen Craig. I work for a startup called Smash Run. It's a website that does running and exercise statistics. And so we're a hybrid of Windows and Linux infrastructure, and I write the cookbooks.
Cool.
And I work for this guy. So.
All right, very good.
I'm Louis Paul. I work for Citigroup. We are on our third generation of cloud infrastructure that we're building. And we're writing it out of the stuff we did in Python, using Chef and Ruby.
Okay.
And we have some tight integration with the fast framework where we're going to do all the provisioning and configuring using
Awesome. You, sir? Sirs? Sir? Yeah.
Ben Gilbert, working with Scholastic. We're looking at integrating Chef into a collaboration framework to leverage Chef developments across our organization.
Okay.
Ben, I'm a big cloud automation project that integrates Chef, vision infrastructure, and management at the enterprise level.
Sure.
I'm Ricky. I work at Huge, and we use Chef for all our projects.
Okay. We skip the front row here. So.
My name's Robert Capazzo. I work at Street Easy. And,
Okay.
We use Chef extensively as well.
Awesome. So you're here with JD. Yeah, I know you, so I don't need to talk to you. Let's go back there. You.
Alex Roman. I work for a company called Laboratory. It's a software service provider. We use Chef to do that infrastructure and also the application page.
Cool.
Tom, I work for a small startup bank called Simple. We use Chef exclusively for all of our ops infrastructure coordination. We use it in sort of a weird way. And I'm very interested in this talk. I'll talk.
Okay.
And I'm really interested in this talk because we're about to venture a project for this exact purpose to do extensive cookbook testing.
Perfect.
I developed my work for WebMD.
Okay.
So we use Cookbook, Chef extensively for automation. I'm beginning to use it to deploy some sensor
Okay.
stuff. And I noticed TravisCI, so
Cool.
My name is Chris Hoffman. I work for a company called Cookbook, doing alternate reality games based on Rails apps. And we're using Chef for our infrastructure for developers right now. And let's get more of that. We're also getting a little bit on testing them, which we're not doing at all right now.
Sure.
I'm just
Okay.
on Jenkins.
Okay.
But I'm looking to check out like Travis.
Sure.
My name's Mark. I work for data on the digital team. We're responsible for maintaining our infrastructure. I'm mostly Chef for the deployment.
Cool.
My name is Christo. I work for Demobilize. It's a converts website to mobile websites, HTML5. So I'm in the process of converting also the usage to Chef. Checking with me and just basically all the pieces work properly.
Cool. All right.
My name is Dan. I work for Shopkeep. All our backend infrastructure is on Linux,
Yeah.
Rails application. Configure all that for Chef. Front end is mainly an iPad application.
Cool.
My name is John Planta. I work for Conde Nast Entertainment. I'm a DevOps engineer there, and we use Chef extensively.
Awesome.
Currently don't testing right now, but
You should. All right. Keep going. This is back row now. So.
Dave, centralized team from the university, network engineering, load balancers, networks, interface with other systems group. Mostly I see it mentioned 2 shop.
Nice.
Not the word.
I'm a nerd about that stuff, so.
I'm Charlie. I'm a network engineer at Blackhawk.
Okay. Cool. And then last but not least.
Mario Morales. I'm a student, a grad student, and I never said college.
Cool. All right. So now that I know who you are, we can get started. Right. So, really quick section on writing cookbooks for those of you that aren't really super familiar with Chef, which doesn't seem to be anybody, but I put it in here anyway. Luckily, it's short. So we'll knock this out right real quick, and then we'll do the testing cookbooks part. So here's how you write a cookbook, right? Make a cookbook. Cookbooks are software artifacts that we're going to test. So software artifacts have name and metadata, right? And then you write a recipe, right? So package template service, well, it's not a template, but yeah, there's your chef recipe. Hello. So that was easy, right? So that's how you write chef cookbooks. We're done, right? But are we, right? Do we just run this cookbook in prod now that we've written it, right? Do you? Sure. Yeah, I mean, some of you do. I wouldn't. I'd test it first, right? So part 2, testing cookbooks, right? So this is a little bit more involved than writing the cookbooks, obviously, which is why you're all here. Here's the basics, right? So to test a cookbook, you run a recipe against a machine and see what happens. That's pretty much it. There's a couple different ways to do this. Manual techniques, how we all started out, how I remember doing this kind of thing back in like 2009, right? I have my VMware, I like snapshot it and then like bootstrap it with Chef and then like rewind it to the snapshot and bootstrap it with Chef again until the bugs were shaken out of my code, right? That sucks. So once you run Chef against the machine, you'd go to the IP address of your VM and see if it works. Turns out it does, so I now have confidence that I can run this on my infrastructure. This is better, right? If you can actually drive testing top to bottom from the command line, that's what you want to do. That's how you automate things, right? So we're gonna get here, right? So the simplest tests I like to call Converge Testing, and that is basically just seeing if Chef Client runs without blowing up, right? Which is usually the extent of testing that most people actually do, right? Does the Chef Client run without blowing up, right? So this is where most people are.
When you say blow up, do you mean the run itself doesn't fail, or the run succeeds with errors, or?
The run fails, or
Okay.
the chef, yeah, there's a syntax error in your code and it won't even let you upload it to the chef server or that kind of thing, right? Like, yeah. So it's totally possible to have a cookbook that correctly misconfigures your machine, right? Like the chef code totally works, but it doesn't do what you meant it to, right? So that's this level of testing, right? So there's this thing, KitchenCI, aka Test Kitchen, right? That's what I use every day. I probably abuse Test Kitchen more than most people in the world, right? So that's what we'll be using today. So here I have my software artifact, right? So in my source directory, I have all my cookbooks there. Actually, I'm lying. I have an opcode cookbook subdirectory, but it's important that there's no chef repo here, right? Tale of two workflows, right? You have like the old school chef repo way when you have your cookbooks subdirectory and your cookbooks in there, right? And then you have like this newfangled Berkshelfy stuff, right? That all arose from the need for testing, okay? So I'll be showing Berkshelf in here too. So the trick is you have to think about the cookbook as a individualized testable software artifact on the same kind of like level of rigor that you would apply to something like a Java library or a Python module or like a Ruby gem or something like that, right? It's not just like this abstract blob of code or something. It's an actual software project, right? So, and as such, it lives in its own source code repository on your GitHub or wherever you like to do. So what we're going to do is we're going to put a gem file in here. And we're just going to put this stuff in the gem file, right? So if you're behind a firewall, you can point this elsewhere, right? If you host your own gem repository, that's cool. But otherwise, if you're out in the public internet, you can point it directly at rubygems.org. And we're going to get Test Kitchen. We're going to lock it down to 1.2 because that's generally a good idea. And then we have Kitchen DigitalOcean. Right. So a cool thing about Test Kitchen is it has a plugin architecture. The one that everybody uses is Vagrant because for some reason people like Vagrant. I freaking despise Vagrant, but to each your own, right? The big reason why I do all of my testing on DigitalOcean is because I live in Bushwick. And when you click on, I pick up 50 or 60 SSIDs, right? So my Wi-Fi interference is horrible, right? And then on top of that, my Time Warner connection is also horrible. So between the two of those, I might as well be on the space station, right? So I can't be flinging up VMs on my machine and trying to download packages and all this junk from the internet. It's just not reliable, okay? So I like to test in a data center where I have bandwidth and SSDs. So I'm testing on DO, right? So cool. So Test Kitchen drives, it knows how to speak the DigitalOcean API, right? And it will upload the cookbooks and test them, right? So you edit your gem file and then you run bundle install, right? And it goes down and pulls down all the dependencies that you need for Test Kitchen and Kitchen DigitalOcean, right? Installs them locally into your localized gem cache, right? Who here is not super familiar with the Ruby toolset and the different things around it, like bundler? So everybody is, right? So I'm not speaking alien to people. All right, cool. So bundle install, we install our gems, and then we have to lay out a kitchen YAML, right? So I actually, in practice, use a kitchen.cloud.yaml. Turns out Test Kitchen actually looks at an environment variable to find the kitchen YAML. So if you export capital kitchen _ YAML, you can point it at whatever file you want, it'll pick it up. If you look at the opscode public cookbooks, I actually ship .kitchen.yaml with the Vagrant version of this, and I'll ship a kitchen.cloud.yaml with the cloudy version of this because I don't want to make people sign up for AWS to test cookbooks, right? The default way is use Vagrant for free on your laptop. So pretty simple. If you've never seen a kitchen.yaml before, at the top there's a driver config. I'm driving this with environment variables, right? So if you were to echo this on my laptop, you'd see my DigitalOcean API keys, right? And then in the platform section, I'm laying out, okay, well, if I want to test on CentOS 6 or RHEL 6, right, I'm going to use the DigitalOcean plugin. And then here's just a bunch of information that you wouldn't know unless I told you, right? So this image ID is what corresponds to CentOS. Unfortunately, these change, right? So when they change, you have to fix it, right? Which is a bummer. DigitalOcean did implement these things called slugs, where you can reference CentOS 6.4 with that name instead of the number, but unfortunately it doesn't work in the Test Kitchen plugin yet, right? Somebody just has to get off their butt and fix it. Probably end up being me, right? So until that happens, image ID, right? Flavor ID is CPU and RAM, right? And region ID is a data center, right? I use NY2 because what's up? So you can find out all this information by querying the DigitalOcean API, right? So for this kind of stuff you get off the website, right? So you can actually go clicky, find this information here. This stuff you can't, right? So you need to learn how to actually manipulate the API. That's here, right? So if you visit DigitalOcean, I forget what the URL is, it's /API or something. It's all documented up and down, totally works. Just curl it, right? So if you want the images, you curl the images, URL, and SSH keys, and regions, and all that stuff that you need to put in your kitchen.yaml, you find by curling, basically, right? I put a ticket in to actually be able to find this from the web UI, but you know how that goes. So this is what happens if you have everything configured correctly, right? So you can say bundle exec kitchen list, right? So what Test Kitchen actually does is has this notion of suites and platforms. So if I go back to here, so I have a suite down here that says, all right, I just want to set this run list when I boot the node. When I test the node, and it'll actually multiply the suites times the platforms, right? So if I had multiple recipes in here, like recipe 1, recipe 2, I would make multiple suites for it, recipe 1, recipe 2, and it would say recipe 1, CentOS 6.4, or suite name 1, CentOS 6.4, suite name 2, CentOS 6.4. So this way you can test across multiple platforms. I'll show you the MySQL cookbook when I'm done with all this. It's got way too much platform support. So here you are, right? You're about to test this stuff. So
Does that have to be YAML? Can it be JSON?
it has to be YAML because that's what Test Kitchen ingests is YAML. So I could be wrong about that, but I've only seen YAML.
Okay.
Right? Ask Seth Vargo for JSON and it'll magically appear, right? So, cool. So now all you need to do is run Kitchen Converge, right? Kitchen Converge will actually use the DigitalOcean Test Kitchen plugin, make the API calls on your behalf. It'll wait for a machine to come up, right? It'll SSH into the machine, upload your cookbooks, and then run Chef client against it, right? Just like Vagrant. So pretty easy. And then at the bottom, you'll see that it's pretty quick, right? I forget, how long does it take machines to come up? Like what's your SLA on machine creation? It's like 55 seconds? Yeah. Sometimes it's faster, but you're looking at iteration times on the order of minutes here, right? So write code, push a button, see if it works. Not very long, right? Cool. And then you can do kitchen list to actually see that your machine is indeed up. And then if you wanted to, you could do kitchen login and look around. And then kitchen destroy actually tears it down, right? Pretty easy, right? Yes, you would do that here. So require Chef Omnibus. Latest will always go get the latest, but you can pin it down to a specific version there. So if you needed to run a 11.2 for some reason, or 10.9 or whatever, you can do that there. Cool. Cool. So that's the easy part. And that's where most people get, right? So cool. So we'll get a little bit more advanced now. We'll talk about integration testing, right? For people that are new to testing, this is kind of the most intuitive thing to talk about. So I'm going to talk about it first. So what's integration testing, right? So integration tests that a set of resources have achieved their combined goal, right? So earlier when I was talking about you can totally have a successful chef run that misconfigures your machine, like this is what you're testing for. So testable intent, right? So each one of these are chef resources, right? They are themselves test and repair mechanisms, right? So every time chef client runs, it's going to test to see if the package is installed. If not, it's going to repair it. It's going to install it. It's going to test to see if the service is running, right? If it's not, it'll repair it. It'll test to see if this file looks the way it should. If it's not, it'll repair it. That's cool, but the actual combination of these things, right? Do these achieve some sort of goal? Right? In this case, the testable intent of this recipe is that it's serving a hello world on the web page, right? So people will do this instinctually, right? They'll log into the machine and they'll go poking about to see if like it's doing the thing that they're supposed to do, right? That's an integration test. You do integration tests all day long without even realizing it, probably, right? The trick here is to automate this, okay? So we're going to automate our integration tests. So Test Kitchen will run integration tests out of band of Chef. And this is important because your tests should be out of band of the thing that you're trying to test, right? It does this with these things called bussers. I don't know why they're called bussers. Do you know the etymology of busser? It's
like a busboy.
Yeah? Oh, okay. Well. Anyway, so here's some of the ones that Test Kitchen supports. Bats, I actually really like Bats way better than ChefSpec because it works all the time, quite frankly. But it doesn't work on Windows, so we're trying to like use ChefSpec when we can. So ChefSpec is what I'm going to use for this talk. Minitest is kind of the first thing that came on the scene in Chefland. I don't like it because it interacts with Chef. Right? Like you can totally access the node object in Chef, which is kind of defeating the whole point of testing Chef, right? So don't use Minitest. And then there's also Cucumber, which is its own topic that I don't like to talk about either. So cool. So we'll go back to our kitchen.yaml, right? And we'll see at the bottom here, I highlight to kind of show you like this suites thing, right? So the suites name is default, right? So you put your tests into your cookbook at this path, right? So you make a test integration suite name / busser name directory, right? And then you put your tests in there, and Test Kitchen will upload them and execute them after the Chef client run, okay? So what we're going to do is we're going to make a test integration default server spec, just a hello spec, right? And that's going to do exactly what we saw when we logged into the machine and checked it out with our fingers. We're just going to do the same stuff in here, right? So we're literally just going to curl the local host and grep for hello, right? And that's going to be our integration test. But it's automated now instead of like a manual thing, right? Which is cool. So what we're going to do differently is run bundle exec kitchen test instead of converge. What kitchen test does, it'll actually converge the nodes, wait till that's done, upload the tests, and then destroy the node, right? So you'll have machines instantiated and torn down automatically, which isn't an issue on DigitalOcean because it's so freaking cheap, right? But can be an issue on like Amazon because it's not as cheap, right? So you'll very, very quickly run up like a couple years worth of like, you know, bills like just by testing things automatically. Then there's this notion of like billing resolution, right? Most places will charge you a minimum of an hour right? So again, on Amazon, every time you run a test, you're being billed for an hour, right? So even if you have machines up for a total of, let's do 15, 30-second, converges on EC2, you just got billed for 15 hours, right? So again, not really an issue when the prices are so low, but whatever. You should see my DO bill. It's like penny, 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 penny. It's kind of funny, actually. Maybe I'll show it to you later. Cool. So this is what happens when you run a kitchen test, right? So it instantiates the machine, uploads Cookbook, runs Chef client against the recipes that you told it to, uploads the server spec file after the Chef client run is finished, checks the exit status of the command, and then tears down the machine, right? So we've just automated our integration tests. Pretty cool. Style testing. This is another kind of testing that people like to do. Most shops have internal coding standards, right? Ops code's no different, right? We have our own set of things. So the first thing that we're doing is RuboCop. So for those not familiar with RuboCop, it is a style checker for Ruby level style enforcement, right? So it's things like, oh, you're using double quotes when you could be using single quotes, or there's no space here, you have trailing white space at the end of your recipe, and that kind of stuff. RuboCop finds all that and yells at you, right? So to use RuboCop, again, you go into your gem file, and then you add RuboCop, right? You tell it to install, update your gem set, right? So it goes and pulls down the thing. There's RuboCop and all its dependencies. And then you run RuboCop, right? And it's going to find all sorts of crap wrong with my cookbook, right? So I'm using double quotes here when I could be using single quotes. I don't have a space here. This line's too long, all this stuff. And it's super annoying a lot of the time, except for when it's not, right? So there's RuboCop-A, which will actually automatically fix a lot of this stuff for you, which is super duper handy. I've never seen it mess up, right? And when it doesn't think it's safe to try to fix something, it won't, right? So it'll fix all that kind of stuff. If you enforce Ruby hash rockets, it'll fix those for you. If you enforce the new hash syntax, it'll fix it the other way for you, so it can fix that. What it can't do is rearrange code blocks, right? So there's a lot of rules in RuboCop, things like never use unless and then else, right? That kind of stuff. It'll tell you to rearrange your code block. It won't try to fix that for you, right? It only fixes the cosmetic stuff. So cool. So RuboCop's awesome. You should totally use it. So yeah. So here's what RuboCop did to my recipe. Awesome. And then they'll add new rules to RuboCop too. So just RuboCop-A is your friend. So cool. So now I run RuboCop and it passes. Awesome. What other kind of style testing can we do? So we got Food Critic, right? Food Critic is chef level style testing. And it'll also catch some Ruby stuff, but it's chef aware, right? So you do, again, right? So we're going into our gem file, we're adding another gem, right? So we have the Food Critic one there now. And then we update our bundle, boom. Run Food Critic, bundle exec Food Critic, and then, oh wait, it's complete -f any. So Food Critic actually will exit 0 all the time unless you put this here, right? So you're telling it to exit non-zero if it stumbles on any of its rules, right? So if you go to Food Critic, that is really high resolution. Oh. Wait, that's not what I'm looking for. Yeah, there's a whole bunch of them here. FC001 was fairly controversial for a long time, which is always use strings in your attributes. They actually turned this one off, much to my dismay. Has it?
Yeah.
Yes.
In master.
Really? Awesome. But yeah, it's chef level stuff, right? It'll actually parse your cookbook and complain to you about chef things instead of Ruby things, right? So, know you a food critic. It is good, right? And let's see, what else? Just a couple words about style testing. It's really, really important that you do style testing. It's because Ruby is one of those like Perly, there's more than one way to do it kind of recipes, and that's hostile to newcomers, right? Like if you've got a code base that's using hash rockets over here and like the other style over here in two different files, like it's somebody that's not familiar with Ruby that's coming into your operations team and trying to like read this code, their head's gonna explode, right? So just pick some style and stick to it, right? Be more Python-y, right? Like so the Python community's kind of ethos is like, so Ruby's like, oh, there's more than one way to do it, man. You can do it however you want. Python's like, this is how you're fucking doing it, right? And like, you should do it that way, right? I think we should be more Python-y in that regard. So, regression testing. This is going to be a trivial example because I have a trivial recipe, but trust me when I tell you that this is also super important to do, right? So, ChefSpec. ChefSpec lets you make assertions about resource collections, right? So you compile your recipe, you can actually say what should be inside of it, right? So let's look at ChefSpec. Again, noticing a pattern here, we're going to add something to our gem file, so add ChefSpec to the gem file. Very good. Bundle update, now we have ChefSpec. Run ChefSpec, there's nothing there because we didn't add any specs. So let's add some specs. So we're going to make this thing called a spec helper. It's just going to require ChefSpec, and then it's going to give us a coverage report at the end of every RSpec run. Okay. And then we'll make the actual specs here. So we'll do spec / this is optional. I like to do it anyway. And then it'll just run all the specs it finds in this directory, regardless of the directory structure or what they're named. So feel free to go nuts with subdirectories if you want. So I'm going to write some specs. So here's the spec syntax. It's different than the chef syntax, but it's predictable, right? So the first thing you need to do is set up a node object, actually. Which will be referenced later in the thing. For those of you not like super familiar with the chef like internals, there's this thing called a run context, right? So every time you invoke chef and run a recipe, there's this object called a run context, right? And inside the run context is a run list, right? And then you, as you're compiling your recipes, you're adding these objects to this thing called a resource collection. So you need to make a run context to put these things in. So compiles the hello default recipe, and then you're just making assertions about the contents of this resource collection, right? So you can just cargo cult this stuff. For starters, I will definitely show you reference cookbooks because you're not going to remember this when you walk out the door, right? But it's pretty simple. It does the thing, right? So I'm expecting for this run context to have this inside of it, right? So I'm looking for a package resource with the name HTTPD with the action install is kind of what this is, right? I'm looking for a service resource with the name HTTPD with the action enable and the action start. I'm looking for a file resource with this name with the action create, and then these parameters. You can actually check for the parameters, right? And I'll show you some better examples of this, but I wrote this on my first try by looking at this recipe, right? So it's very predictable, right? So as you can even write your specs as you're writing your recipe if you're confident that the recipe is going to do what it's supposed to. I tried to do TDD, and then I failed at it because the thing I realized was like, I don't know what the recipe is supposed to look like half the time when I'm sitting down to write the recipe, right? So there's a fair amount of like reverse engineering that has to happen first before I'm able to write the specs, which you're supposed to write first, so what the hell. So when I think ChefSpec, I'm thinking, like, ChefSpec's important to me for regression testing more than some blind adherence to TDD, right? But it's super important. But I would expect the chef run to have install _ package HTTPD, right? Enable _ service HTTPD, create _ file, that title, right? And that's exactly what it looks like. Start service HTTPD, create file, that type, right? So cool. And then I run RSpec, and then it shows you 3 examples, and then it shows you a coverage report, right? And because I put a spec on all 3 of my resources, I have 100% ChefSpec coverage, right? These can get long. I'll show you the MySQL cookbook when I'm done here, but yeah. So if you want to know more about ChefSpec, here's where it lives. So Seth Fargo /ChefSpec. This is probably the most important directory on the whole project. It's examples, right? If you go into there, because the syntax isn't always super predictable like that. So for things like remote files, I don't know, like sometimes you'll try to guess the spec syntax and it'll be wrong and you'll be like, and you have to go look it up. And that's where you go, that's where you look. So ChefSpec /examples. Cool. Reference cookbooks. In the past 6 months, we've managed to rewrite all these from the ground up. I have a couple more in the works. But yeah, so this whole thing that we're doing here, like Test Kitchen 1.0, ChefSpec 3, like all this stuff, this is all kind of came to existence in the past, like since like November, right? We've just now really had the ability to do this level of testing recently. So because of that, not all of our cookbooks are that well written, and Yum is written from the ground up with specs on it, full spec coverage, full integration testing, full like the whole ball of wax. Yum EPEL consumes the Yum resource, MySQL, Jenkins, it's all just fully done. So if you need like testing references to look at, like pick any one of these and go in and you'll be able to see examples on how to do various things. Cool. Dependencies, everybody's favorite topic. So cookbooks have dependencies, right? So often a cookbook will depend on another, okay? So this usually manifests itself in one of 2 ways, right? So you'll have the include recipe directive. So I will say include recipe, another cookbook, and then a recipe out of it. Or you'll consume a resource shipped in another cookbook, right? So the Yum repository resource is shipped in the Yum cookbook. The apt repository resource is shipped in the apt cookbook. If you're on Windows, all of the Windows resources are shipped in the Windows cookbook, right? So you very often need to depend on another cookbook for resources or various things. So for example, let's go back and edit our recipe, right? So I wanted a MySQL service on my machine, right? So I'm going to use the MySQL service resource that ships in the MySQL cookbook, right? So it's not in Core Chef, so I need to put a dependency in the cookbook, right? So let's do that. So I open my metadata, I make a dependency, right? So I'm saying the hello cookbook depends on the MySQL cookbook, right? So dependencies suck, and you don't want to manage them manually, right? So to address this problem of dependencies sucking and not wanting to manage them manually, Berkshelf was invented, right? So, yeah. It was the meme of the week at the time that he wrote it, so I was going to call it Berkshelf. It has good SEO, right? It's like probably the most Googleable tool in the entire chef tool chain, right? So cool. Again, we add this to our gem file, right? So we'll add Berkshelf to our gem file, and we'll use bundler to install the gems. Berkshelf has a lot of dependencies. So Berkshelf is bundler for chef cookbooks. Oh, I thought I had another slide in there. I didn't. Oh well. Yeah. So that's all it does, right? So don't be scared of it. You hear Berkshelf's complicated and all this other. Like, no, it's not. It's just a dependency resolver. Okay. So this is how you use it. You say, well, you have to make this thing called a Berks file, real quick. Berks files will point you at a Berkshelf API. Or you can point it at your internally hosted Chef server, right? So you can actually use your Chef server as a cookbook artifact repository with Berkshelf, which is cool. And then it has like its whole configuration file if you need it, but we don't. API.berkshelf.com. This isn't strictly necessary. There's an API thing now in Berkshelf 3 that wasn't around in Berkshelf 2. This is only if you have a quadrillion cookbooks, right? So Riot Games abuses the shit out of their Chef server. They have this whole like CI pipeline, do all these things. Like they will have thousands and thousands and thousands of versions of a single cookbook in their Chef server, not to mention thousands of cookbooks, right? So they're really pushing the limits on Chef server, but it's so many that they actually need to like cache the graph. So you build these dependency graphs, like you have this top level cookbook that depends on these 5 other cookbooks, and each one of those 5 other cookbooks depends on 10 other cookbooks, right? You have this big mess of dependencies. They actually cache that stuff in the API, right? So when you're hitting this API, like that's what it's doing, right? It's speeding up the resolution process, right? Unless I'm wrong about this. But sound about right?
We use Berks API.
What?
It just speeds up the resolution.
Yeah. So, cool. So this is what we're doing, right? So we're going to say Berks install, right? And it's going to resolve the cookbook dependencies. So just like we were doing with the gem files earlier, we're doing the same thing with our cookbooks, right? So it's actually going out to api.berkshelf.com, which is just turning around and looking at the community site, right? And it's saying, oh, the latest version of the MySQL cookbook today is 5.2.12, right? So it uses the latest unless you tell it otherwise, right? And again, very important, you can point it internally, right? So you don't need internet access to use Berkshelf, okay? You can use your own Chef server, so cool. So bundler installs dependencies into your local gem cache, right? Berkshelf installs dependencies into your local cookbook cache. That's it. That's all it does. So, cool. So now what we're going to do is we're going to go in and look at our spec helper and add a line. So ChefSpec actually has Berkshelf integration, right? So when you run your specs and it sees a dependency, it'll go ahead and do all that for you in this like sandbox over here, so you don't have to worry about it. So let's add that MySQL resource to our spec, right? So we have our package HTTPD, service HTTPD, and then the file var www HTML index.html, and then that 4th resource that we put in our recipe right down here, right? So we're adding a spec to our recipe as we're writing it. So bundle exec rspec, 4 resources, 100% test coverage. And then of course, we can run kitchen test, right? And it does the same thing. It'll install the cookbook onto the node that it spins up in DigitalOcean, run Chef Client, run the bussers. But I didn't add an integration test because it doesn't really do anything. I just added the MySQL service resource as an example. If the recipe was a little bit more developed, right? So like, let's say I actually made a PHP app that installs like a database table, like I would test for that in my integration tests, right? But I'm not, so I didn't, so cool. All right, so TravisCI.
Is there actually a busser for ChefSpec now? Because it wasn't a couple months ago.
A busser for ChefSpec? No. So ChefSpec runs locally on your laptop. It's fast in memory there. You don't need to create a machine and then like upload your chef specs and then run them there. You can just run those anywhere, right? So Travis, So I was doing all this on my laptop, right? And sometimes I like to close my laptop. And when I close my laptop, the tests stop, right? So yeah, or if I'm on an airplane or whatever, it's like annoying to have to like do things. And then I'm out of slides because I just started working on these yesterday. So fuck it, we're doing it live. Cool. So Travis, for those of you who aren't familiar with Travis, it's a public CI system, or it's public CI system. Yeah. There we go. TravisCI.org. I'm going to turn the resolution on my laptop down a little bit here. Desktop. Wait. Where's the resolution? I like to tell my computers what to do instead of asking them, so it's a little weird for me to have to color. You know.
The scale button.
Where?
A little higher, a little higher.
Scale.
Scales right here, button. Two more up.
Displays. Oh,
Right there.
scaled. Ah, I see. Much better. Okay, you can go away. Cool. So this is what happens when you go to TravisCI.org. You'll see other people's projects that are running on Travis. Let me fix this. Cool. So we can sign in with GitHub here, up on the right. So I am now logged in as Sean. And so the repos that I have access to just kind of come up here, right? And it can go and try to test things. So I am going to enable testing on one of these cookbooks. Let's see here. Actually, oh, it's my personal one. Okay. The wonders of live demos. Okay, where's the settings on this thing? Status. Accounts. Oh wait, here we go. That's Cookbooks. Here we go. I'm going to enable it on the MySQL Cookbook because it's non-trivial. On. Cool. So what's going to happen now is it's going to watch for commits on the opscode MySQL repo, and when it sees one, it'll go ahead and try to test it, right? So MySQL. So MySQL is a big, hairy cookbook that has lots of tests. So it makes a good example. So this is all it does, is it uses that MySQL service resource that I showed you earlier. As I was using it as an example, and then it reads some data from node attributes, right? And it makes a MySQL service, which is a lot more complicated than it sounds. Turns out that there's a lot of work to do. So if you look at the libraries in this cookbook, pick a operating system. Ubuntu. Plan 9. If you can easily write a Plan 9 provider if you have servers Ubuntu. I'd be interested to get this running on Plan 9 just to. It probably happened before Windows at this point. But it turns out this has a lot of like resources actually embedded inside of it, right? So as I was writing this cookbook, right? So I'm like testing against all like these services and executes and directories and templates and all this junk here. This is all has 100% test coverage, right? So if I was to do B, or I have a alias for bundle exec called B because I'm lazy.
What's it doing right now?
It's running tests. So that was 554 spec tests that ran in 30 seconds, right? The reason there's so many tests is because it actually, for realsies, does support all those platforms, right? It doesn't just say it does and then kind of crash halfway through it. Like it really, really does. And spec testing is super important because like very often, especially with like the cross-platform public cookbooks that people write, very, very often people will like, oh, this doesn't work right on, you know, my operating system, or like, oh, like Debbie and Jesse or whatever they're testing it on. So they'll send a pull request that will fix their issue, and then it'll like break like Solaris, right? So if you're ever like dynamically generating resources or like actually using like the Ruby part of Chef to like write your policy, it's super important that you write specs against it, right? This gives me the confidence to accept like pull requests from people, right? If I can run the specs real quick and like see within 30 seconds that this didn't blow up like 6 of my platforms, like that gives me confidence that I can merge the pull request. I don't have to actually go and run the integration tests on all the platforms, right? So like that's why spec testing is important, okay? So this isn't gonna run on Travis until it sees that there's a change. So I'm gonna take the README and I'm gonna add a smiley face to the bottom. Adding smiley face. Git push origin master. If you ever see weird commits in Chef cookbooks, this is how they happen. Cool. So Travis should see that that has a change to it, and it should start running the tests. Hello. Sometimes Travis is a little slow. Oops. Fine.
Does it watch, or does it get some type of push notification?
Tell you what, I'm not really sure. I would imagine it watches.
I think it installs on my book.
Does it?
I think so, yeah.
Okay. Where'd my thing go?
Yeah, GitHub pushes to Travis. Right.
Yeah.
Travis will set up a webhook in your Git repository so we can push it in.
Oh, really? I thought I had it enabled here. Wait, how do I enable it here? Yeah, it's already there. So yeah, so I flip this on and eventually it'll see that. Oh, there it goes, cool. So it's been testing the MySQL cookbook for 30 seconds. Right. so it sees that it's a Ruby project. So Travis has a bunch of stuff already like kind of installed on the boxes, and it's using various cloud providers like will donate boxes to Travis to use. So like Blue Box ends up with a lot of machines on there. It's all open source, it's all free, right? So it's like, you know, please may I have some boxes. But these boxes have like, you know, compilers like Make, GCC, that kind of stuff already installed on it. They'll typically have like language runtimes, right? So it's going to have a Ruby, like RVM kind of thing available to you. It's going to have Python, Java, these sorts of things available. So you can like upload your JavaScript project to there, and it'll have the runtimes on there, and it'll test it for you. So it sees that there's a gem file, so it's going ahead and installing these gems for me. Do I have a Travis YAML in here? No, I don't.
It says you don't.
What?
It says you don't.
Yeah. So it's not going to know what to do, so it's just going to install the gems and then stop, probably. So what I would do to drive this is I would create a Travis YAML, right? So I'm going to cheating. What? Like you don't do that? Cool. So this is a Travis YAML. Right. Yeah. So basically, you put stuff in here, right? So you'd say script, right? And you'd say like bundle exec, rspec, bundle exec, you know, food critic -f NEI. So like all those commands I was typing on my laptop to make this thing go, put your Travis YAML, right? There's a bunch of other crap in here that I'm going to show you that is not. I'm not actually going to go all the way through this and show you how to do this, but I was experimenting with doing my integration tests on Travis as well, right? So committing something to Git and then having Travis actually spin it up on DigitalOcean for me because I'm on an airplane and I don't have a solid internet connection and I need to test. Right. So this is me doing that. Release engineering made me stop because I was tying up all the Travis workers. You only get so many like Travis workers to yourself per machine, and I was using them all because I was testing cookbooks, right? So they made me stop doing it because we couldn't get anything else tested on Travis because I was taking up all the bandwidth. To do that, I needed to do some tricks, right? So you'll remember my kitchen.cloud YAML. So this thing is powered with environment variables that have my DigitalOcean API keys in them, right? This isn't necessarily sensitive, but this is, right? So this is my SSH key. Like so, on DigitalOcean, I uploaded the public half of the SSH key and the private key. This is just a path. This will say, if I was like echo this, it would be like //.ssh like travisdo.pem, right? I need to have that to log into the box to upload the cookbooks to start the chef client, right? So I needed to put like two distinct sets of secrets. So I need my SSH private key, a dedicated SSH private key, but an SSH private key nonetheless, and then my DigitalOcean API creds, both to be available to TravisCI. Did some crazy. So it has this thing called secure global environment variables. So all that gobbledygook on the screen that you see here are environment variables.
Is it just base 64?
No. If you do, okay, let's.
Travis encrypt.
Yeah. I'll just take all this crap out. I don't need any of this stuff. Okay, so I just took that out, right? So if I was to say, wait, is this right? So I have an environment variable. Oh. I haven't done this in a while, so. Damn it. All right, well, however you make that work, right? So you'll say Travis encrypt, and it'll actually stick like that blob into your Travis thing, and then it'll decrypt it during your Travis run, right? So what I ended up doing here was writing this mess of awk here. So I needed to take my SSH private key, put it in an environment variable, and then write that out to the key before I did my Travis run, with the added difficulty that Travis environment variables could only be like 90 characters long, right? So I had to chunk up my SSH key, encrypt it into a series of environment variables in my Travis YAML, decode them, append them into my SSH key, right? So this is what this is doing, is it's just saying, you know, I'm walking through all 30 chunks of my SSH key and like appending them into the SSH keys for different clouds. I test on DigitalOcean for most things, right? They have pretty much every platform, like Linux platform that you'd want, right? So they have like CentOS 6, 5, like Debian, like all the Ubuntus, like all that junk, like they have like available for use. I use Amazon to test Amazon Linux because it's only on Amazon, right? Like you can't test Amazon Linux on DigitalOcean or anywhere but Amazon, so I have to use Amazon. I test SmartOS on Joyent because that's the only place you can get access to a smart machine is a Joyent public cloud, right? So I do this for different things. But again, like I stopped because people told me to, because I was using up all the bandwidth. Right. The tricky part though is that you can't do integration tests with pull requests this way, because if you were to send a PR to my Git repo, Travis would be like, no, because it's not going to want to. It can't decrypt the environment variables, so it's not going to do anything anyway. So what it can do is it can run the spec and style testing, right? So it can do a subset of the testing, but it won't do the integration testing on PRs. I'm currently searching for a way to securely do automated integration testing of pull requests on Cookbooks, right? That'll enable me to merge things much more quickly. A couple other issues with Travis were, let me think. So they're 10,000 line maximum output buffer, right? So if your test kitchen runs or exceed more than 10,000 lines, you're not going to be able to see the bottom, right? What else? There's a timeout. There's a maximum time of something around a half an hour, I think. I can't remember. So if you're doing this, right, that's not going to survive a single test kitchen run, right, on Travis. That's going to take too long to do in serial. And then if you try to do this in parallel, concurrently, sorry, there it goes, and it's spinning up a bunch of stuff in DO, and every instance has a different color. So you're gonna see this like mess of like stuff coming back. But this is gonna blow up about halfway through it. I forget why. I think like an image ID changed somewhere or something. Yeah, I had to fix Heartbleed, man. Like, come on. But this will blow up. But the run will stop, but it'll leave the instances dangling, right? So if I'm doing this on TravisCI, I'm gonna have these dangling instances that I have no way to like, because you can't log into Travis, right? You can't be like, oh, my build failed, let me pop in there and see what's going on and clean up after myself. Like you're just done, right? Like Travis is like, okay, here's your output, 10,000 lines of it, like, what do you want, right? So this is gonna explode, and I'll show you that. So there's there's issues around doing this, right? So I'm not actually doing integration tests on Travis currently, which is a bummer. But I'm currently kind of exploring this public CI space, which it's interesting because like we have unique needs with our testing, right? Like most people are just like, oh, Jenkins behind the firewall, you know, like, and they're all working on the same team, so some of the security issues are mitigated. Like Travis actually does let you give them money, right? So you can pay Travis money and they'll run it on dedicated infrastructure and everything, but it only works on private GitHub repositories. My Git repositories all have to be public because we're an open source project, right? So I can't actually use for pay Travis on public stuff, right? And then for automated integration testing, I have the problem of, well, if I'm going to be doing pull request testing from the wild internet, right? I can't have my like cloud credentials exposed. Like I have to assume that the code's going to be hostile, right? So you can send a PR that will read your environment variables and mail them off to China, like pretty easy, right? So I need to account for that too. So I have an interesting kind of like interesting problem to solve with integration testing. Wow, this hasn't blown up yet. So that's basically all I have for you, except for I'm going to clean this up when it explodes eventually.
Destroy will always.
What?
Kitchen will clean up your instances because you destroy will always.
Yeah?
And so it doesn't matter if we're on pathway, it'll just blow away all your instances.
Cool.
Regardless.
The more you know, right? So, questions? Comments? Yes?
So we use Test Kitchen as well for something similar to this, custom baked solution for EC2.
Yeah.
But I saw your ChefSpec work, and I was wondering, like, why can't we just rely on ChefSpec to do all this? Because it seems pretty exhaustive.
You can, but I mean, like, so ChefSpec will let you assert that the resource collection is what it's supposed to be,
Yeah.
but
All of the right arguments.
it won't let you assert that you have a functioning web server that's serving the right data,
Sure.
right?
So basically testing the underlying chef pipeline, like
Yeah.
plumbing work there, make sure the files get in the right place.
Exactly.
Basically unit testing.
Yeah, it's your unit testing, right? So I don't know what happened to this, but oh. So like if you look at here, let's go ahead and look at MySQL. Set up. Right. So taste the rainbow. Let's make this bigger. So CD test, integration, server 5.6, default. like, this is why you actually spin this up on DigitalOcean. It's so that you can run this test, right? Like, you can't do that with ChefSpec, right? You can't be like, hey, you can't check to see if the service is running and if it answers data, right? You can libraries. Ugh. No, not you. So here's the rel provider, right? So it turns out, if you want to install different versions of MySQL on Red Hat or CentOS or anything like that, you have to use this thing called software collections, right? Which sounds like a really good idea at first, but turns out they're super annoying because they push everything over into /opt and they make you run special commands. It's like, it's complete madness. So the recipe looks rather ugly, quite frankly. And then there's like different differences between the platforms where, like, so if I wanted to move, so here's an example of me dynamic resource, right? So this variable changes, right? So you're passing in to the MySQL service resource a data dir, right? So you can test for that. This baster thing, like that changes, you know. So if somebody finds a bug in, you know, like Red Hat 7, right? Let's say somebody like Red Hat 7 comes out and they go to run this thing on it, right? And it blows up, right? They can fix it, send the PR, right? And then I can just run ChefSpec on it and be and have certainty that it's not going to blow up. Like, I don't need to run the integration tests on Debian and FreeBSD and OmniOS and all this stuff.
Also like an OS level test at that point.
It's a code level test, right? Like, it's a chef level testing.
Because you know then that Chef is not going to be changing the resources for those other platforms.
Right, exactly.
So you're just shortcutting the need for all of those other high-level integration
Yeah,
tests.
exactly.
Cool.
Yeah. So that's why ChefSpec for regression testing is super important to do. So this should be done. Okay, cool. I'm done. Any other questions? Going once, going twice. Sold.